All right, and so we're going to get started. Welcome everybody to our 2025 NSF CI Compass virtual workshop. The topic of the workshop is data management from instrument to first storage. And this workshop is organized by CI Compass. I'm the PI on this project. My name is Ewa Deelman. And the mission of the NSF-funded Cyber Infrastructure Center of Excellence, CI Compass, is to provide expertise and active support to cyber infrastructure practitioners at NSF major and now also mid-scale facilities in order to accelerate the data lifecycle. And so when we look at the data lifecycle, we designed or we modeled it as a number of stages. The first one is really the data capture at the instrument, where the instrument basically collects data either from the environment or for a particular experiment. Then it goes through initial processing, so some data cleaning, maybe data tagging at this point. And then to central processing, where additional science products are generated. The data is stored in a data center for preservation. The data is additionally curated, archived, and then the data is disseminated to the public. The data may be visualized at this point as well. And data access is provided to scientists, to educators, the students, and the public. And obviously, various stages of a data lifecycle are present in different forms within the different major and mid-scale facilities. There are also some cross-cutting elements that go across the many stages of a data lifecycle, including data movement, fair data, identity management. And so we want to be able to understand the various stages of a data life cycle, and moving forward, we want to step through them and see what are the challenges that the facilities, the research infrastructures have within these various stages, and what are the best practices that they use, and share basically their experiences within our community. So this workshop focuses on the first stage, so really looking at capturing the data at the instruments, looking at issues of data tagging, so this initial processing, maybe cleaning the data, and so forth. So when we talk about the data within the major facilities, the research infrastructures, there's a helpful way, at least for me, is to look at the data in terms of who are the actors in the data collection, in the data acquisition, in the use of data for generating science, and in data publication. So you can think of these different data types in four different categories, and one of them is collective data. So this is, you can think of a large high-energy physics experiments such as CMS, neutrino science such as IceCube, gravitational physics such as LIGO. So in these type of experiments, data is collected, calibrated, and analyzed by collaboration. This collaboration has all the details of the data collection. They can influence how the data is being collected. They often build the instruments that do the data collection. And then the data is typically first disseminated within this collaboration for the purpose of research. And after a period of time, the data is then disseminated more broadly, and additional data products may be derived from that at that stage, and also by the larger community. The collaboration scientists in this case are very familiar with the data. As I mentioned, they often build their instruments themselves. And so although the data can be very complex, full detailed data and metadata have a single steward, and so the knowledge about what is being captured is known to the community. Now, if you look at other types of research infrastructure, you can think of them, and now I'm thinking of things such as EarthScope or NEON or OI. you can think of these more as community data. So in this case, data is collected by research infrastructure for the purpose of generating data collections. This research infrastructure typically does not conduct research on the data, and the data is released almost as soon as it's being captured. And then the scientists use this data, and the public may also use this data to look, for example, at recent earthquakes or data collected at various neon sites and so forth. But the scientists and the public that use this data typically have limited influence on the data collection itself or the analysis that's being done on the data and to generate science products. So they have also little influence, but also limited insight into the exact collection of the data or the analysis mechanism. So the burden is on the research infrastructure to provide not only the data, but also detailed metadata so that the data can be interpreted by the scientists and the public. And so of all this community data is very complex. The research infrastructure has that information about the data and metadata and can provide this data to the users. Now, the situation, I think, is a little bit more complex when you're talking about user facilities and research infrastructure such as MagLab or the Near Wave Research Lab or the CHESS synchrotron, where the PI is really the main actor in collecting the data. So they're conducting an experiment at the facility, and with the help of a research infrastructure, they might also bring in additional instruments to the ones that are provided by the RI. They usually collect the data with a specific goal in mind, so they have a particular research that they want to conduct. And so sometimes this information that is implicit in the data and may not be captured or made broadly available. The data products depend also on the main instrument being used, main facility, but also the potentially additional instruments that the researchers bring into the research infrastructure. So in this case, research infrastructures typically don't have ownership of the data. It's the PI is the one that has the responsibility to distribute the data and adhere to the FAIR principles. So in this case, metadata and data have multiple stewards, so you might also have sample preparers that are in the mix, which are different from the experimenters. And you have the research infrastructure experts that are helping set up the instrument and the experiment as well. So the situation, I think, is quite complex and challenging. And then also you have some hybrid data where you can think now of research going vessels where the data is collected primarily by the PI again for their own, during the cruise, using potentially their own instrument, but also the instruments on the research infrastructure on the ship. And then the data that's released to the public comes both from the research infrastructure, but also the data that's collected by the PIs is also of great scientific value. So now you have this situation which is hybrid, where the metadata and data have multiple stewards that are distributed between the experiment and the research infrastructure. And again, the PIs might not have sufficient knowledge of CI, the tools and resources to make data fair. So the situation obviously is quite complex. And so in this workshop, we're trying to address the challenges and best practices and also possible solutions to this first stage of metadata and data capture. So issues of metadata tagging, enabling fair dissemination of data, managing data streams coming from the instruments, the various choices of storage and database technologies that people make. We can also talk about on-the-fly instrument control and also incorporating user-specific instruments. So we have a great schedule that's over the next 3 days, starting at every day at 9 p.m. Pacific. Today we have 4 talks, and on the following days we have additional talks by the various major and mid-scale facilities, as well as cyber infrastructure projects that work in this area of data collection and from this first storage, collection to first storage. So the format of the talks will be 30 minutes. We have the slots that will start punctually on time. The presentations will be 20 to 25 minutes with 5 to 10 minutes of questions. We'll interrupt the speakers if we go too long to make sure that we stay within our time frame. All the talks will be recorded and available on our website and YouTube channel. So obviously, I know people's schedules are very busy. So if you miss something, you can look at it afterwards. In terms of asking questions, please raise your hand. If you can't, then please put your question in Zoom. However, we ask that after the presentation ends and you have further questions, please use our Slack channel, and we should have information in our Zoom chat about how to join the channel. Afterwards, after the workshop, we'll conduct a survey to ask you feedback about the workshop itself, and we also generate a report. So I think with this, I'll stop sharing, and I'll invite our first speaker to share his presentation.